So, just a normal day, nothing special. Oh, we are having a quiz on Wednesday.
Oh,
Fun times. This warm-up is based on stuff you should have learned before, so hopefully this is a little review. But can you simplify these expressions? Now, if you look at number one, there's 5 terms. If I want to make that simpler, what am I going to do? What's that phrase?
simplify.
Yes.
Make smaller.
Combine like terms. Combining like terms. Y'all have heard that before?
Yes.
Okay, so let's combine some like terms. We start with the highest degree, the highest exponent, which is squared. Now, this is where most people goof up. Check it out. Do you see the first x squared is a positive 2x squared, right? So I like to circle my stuff so I know what I'm doing here. So this is a positive 2x squared. But the other x squared term is what? The common thing people would say is 10, but do you see the sign goes with the number? It is a negative 10x squared. This whole thing is one term, one thing. So if I can combine those two together, what's 2 minus 10? Two minus 10. What's 2 minus 10? Negative 8. Thank you. 2 minus 10 is negative 8. It's negative 8 and what? X squared, yes. Do y'all see how that combination works? You add the coefficients out front with the sign, and then you keep the exponent the same. Now, what about after squared, we go down to just regular x terms. So we have a negative 6x and a positive x. Okay, what number goes in front of that x with no number? 1. That's a 1x. Write it to help yourself out there. So when I combine negative 6x plus 1x, what do I get? Okay, negative 5x. Please notice that you're adding just the coefficients, not the degrees, not the exponents. Okay. And then what's left is one little constant plus 3. Hey. So that plus 3 is going to go right here. Do you see how the degrees are descending? Highest power, then the next, and then down to constant. Okay. Can you combine like terms today is the question. That was a very confident, resounding yes. Good job. All right, now, number 2, though, is not adding. Do you see how there's some parentheses? What does that imply we're going to do with this outside term into the inside terms? We're distributing, which is what operation? Multiplying. So we're going to do some multiplying. Looks like this. I like to draw my little arcs. This times this times this, and this times this. So let's remember how to multiply variables with exponents, right? So check this out. I'm going to zoom in. Whoop. I'm going to zoom in real big. Extremely big. All right. Go down. Now, 3x times x. We're going to start with that one right there. Okay. Now, here's the deal. When I have 3x, what exponent does a regular x have right here? 1, right? X means x to the 1. Go ahead and draw that little. So when I multiply 3 times no number in front here, which is 1, I get 3. Now, this is a very important rule. Is everyone listening? Everybody? Okay. What do I do with these two degrees? The exponent 1 and the exponent 2, what do I do with those two numbers? Add them. Okay, I heard multiply, but we don't multiply them. We add them. Okay, so you multiply the base, but you add the exponents. Okay, that's the power rule. Very important information. I want to make sure you can hear me and not anything else. And then, okay. So we get 3x to the 3rd power. Does everyone see how that works? Multiply the base, add the powers. What do I do with the powers? Multiply the base and add the exponents, powers, like whatever you want to call them. Okay, let's do it again. Ready? 3x times negative 2x. Okay, so we're going to multiply the base. What's 3 times negative 2? Negative 6. And then x is a 1. What do I do with these exponents again? Add them. So x to the what power? We have x to the 1 times x to the 1. I add the powers, so it's squared, 2, okay? And then last one, 3x times 5. Okay, 3 times 5 is 15. Don't forget that x goes with it, right? It stays with it. That is simplified because you've multiplied into the parentheses. That's it. None of those can be combined because they all have different exponents, right? Okay. That's our warm-up for the day. Now, we did that on purpose because you're using those skills on the notes today. We'll pass this out.
Candy Crush.
We play Candy Crush, Daddy.
Yeah. That's two other things.
Candy Crush.
I thought
He was on the play. I'm gonna tell her. Find out one way.
I saw you. Him, he's I was like,
You were walking there, see.
I know you threw out
Okay, here we go. Whoa. All right, ready? Everyone looking. So we have 4 examples. It can go pretty quick. We just got to focus. So 7.3, we're going to be able to add, subtract, multiply polynomial expressions. Here we go. This is not in your notes, but this is background information, stuff you've learned before, hopefully. So look up here because you're not writing this down necessarily. Look. Standard form of a polynomial function is a function with one or more terms. It's actually an expression, not a function, whatever. Exponents are non-negative integers. That means your exponents are going to be like positive numbers that are not decimals, okay? Coefficients and constants are real numbers, okay? None of these numbers will be imaginary. There are imaginary numbers, but we're not going to use them today. And then here's how you classify polynomials. Monomial, mono 1, binomial 2 terms, trinomial 3 terms, poly for 4 and up. All right? So imaginary numbers are of the form square root of -1, because you can't square root a negative number, but you can still do math with it, even though it's impossible to do. And it's a 2-dimensional number instead of a 1-dimensional number, and you can do a whole calculus over it. I have a book from my college class called Complex Variables I can show you right now. It's crazy.
You know what sounds crazy? An impossible number.
I know. Yes. We'll get there. All right, now back to real numbers. Now look at this. This is a good polynomial standard form. What do we call it? Standard form of a polynomial function. Do you see how the highest exponent is 4, then it goes 3, 2, 1, nothing, right? Notice the leading coefficient is in the lead at the front. It's a coefficient in front. And these are the names of the different functions. We have quartic for 4, cubic for 3, quadratic is 2, linear 1, and constant is none yet. Now, let's do example 1. Y'all ready? All right, now, we have 2 functions. We got f of x, we got g of x. Okay, that's just facts. And then what does it say to do with f of x and g of x? The problem is we need to do what with them? Add them. Just like number 1 on our warm-up. Can't you combine like terms?
Yeah.
Yes, okay, thank you so much. Now, here's the way the notes want you to do it. They want you to write this on top of this, off to the side, or down below on your paper, and you're going to line up all of your degrees. So your third power is going to be in a row, second power, okay? But let's notice something. Look at the first f of x. We got 3, we got 2, and we're missing x. On the second one, we have 3, and we don't have 2, 1, 0, okay? So do you see how some of the stuff is missing here? When we write it, we're going to make sure we don't forget it, and we're going to write a 0 term. So when I rewrite f of x, go and write this down. Okay, I'm going to rewrite below, number 1. Okay, when I rewrite it, since the 1x is missing, I'm going to make sure I put it. I'm sorry, since the x term is missing, I'm going to put 0x there. Hope that makes sense. If you got something missing, you can write it with a 0. Cool. Hey, don't think of riffs, think of math. Right? Right? Yeah. I wrote that riff. Now, let's write the second equation, g of x, and don't forget to put a 0 term for the x squared right there, because it's missing. So everyone's writing this down. You're writing this down. Once you have it lined up, then you can do the math. You can add them up. Right? Oh, yeah. Yeah, if you're already there, go and start adding them up. See if you can do it.
Great. Okay. How do we?
Let's do that. Let's do the first column.
Let's skip first grade.
What's 2x cubed plus 8x cubed? How many x cubed is that?
5.
And x cubed. Remember, the exponent stays the same when you're adding. All right, well,
So the next one's still just 1, right?
1x squared, yeah, which is usually just x squared. What about the next one?
Wait, is that a minus or a plus?
-6. -6.
Negative 6x, yeah, because the x is there, right? And then on the last one,
-3.
negative 10 plus 7 is what?
15.
Wrong.
Damn it.
What? Negative 3. All right. Now this is the answer. The only way you would write it a little bit different is that you don't have to put the 1 power. You don't have to put a 1 coefficient. It's kind of implied. So that's it. Could you do that and combine like terms?
I could try.
That is the easiest one, so I really hope this is like, yeah, no problem, Mr. G.
Well, I can try.
It's the easiest onesie on this.
Well, you're probably going to give us harder ones, so we can try.
Yeah, but now
No, I think it'll be over 7-1 and 7-2, probably. I'll give you a little review tomorrow, so you have a little hint, you know, a little foreshadowing. Now, ready for example 2? Who said no? All right, here we go. Example 2.
I just had that.
No doubts. All right. Same idea. Can you take 2 functions, but one little difference? Check it out. What are we doing with f of x and g? Hey, what are we doing with f of x and g of x? Does everyone see it? If you always assume you're adding, you're going to goof up. What does it say? What does it say? All right, minus, fraction. Now, this is going to change one little tiny step. Very important step. If you don't do the step, you get it all wrong. Many tears will be shed. Let's go ahead and write this out. Notice how x squared and x are missing here, right? So we want to make sure we write it all down. don't forget your 0 terms that are missing. 0x squared is missing. 0x is missing. So everyone's writing this down for number 2. Wow.
That sounds amazing, sir. That sounds nothing like a dying horse. Have you heard what a dying horse sounds like?
Yeah.
And let's go ahead and write g of x underneath it, please.
Sarcastic then?
No.
All right. Now, we're missing x to the 4th power. Okay, so you can put a 0, x4. Now, some of y'all might be eager to go ahead and start adding them together, but let me ask you, are we adding these together? No, we are subtracting. Okay, I want everyone to write this down before I make a big fuss about this, because I'm about to make a big fuss. Big fuss. Everyone's written this down? Write this down? Written down? Written down?
No, I don't.
Okay, does everyone see this little bubble right here? Let's read it. Subtract means you have to change a sign of the entire g of x. Okay? So currently, g of x has a minus and a plus and a minus and a plus. Okay? Notice what's about to come up here in red. Okay? That minus 1x cubed is going to become a plus 1x cubed. Okay? The plus 1x squared is going to become a minus. Minus is going to become a plus. Plus is going to become a minus. Does everyone see these changes? Because you're subtracting, you have to change these signs or you'll get it wrong. It's so important that people get it wrong all the time because they don't do this step. It makes me stressed out that y'all don't do this step. So does everyone see that you need to make sure you change all these signs? Forget, I will be sad. I'll shed one tear.
That
is it.
Yeah. That's all I heard was Mr. G.
All right. Does everyone understand? When you subtract, change all these signs. Now you can do that combining thing we did last time. Let's combine. Ready? So, check it out. 2x to the 4th. Bring it down. 2x to the 4th, bring it down. Now I'm going to do 9 plus 1. What do I get for my x cubed? I was just rewriting the original one, which is right here. I would rather you not, because this can be kind of difficult, and I want you to miss it. You can, I'm just saying. We're about to do the hard stuff that you might miss, and you'll never learn it, and you'll be sad. All right. Now, what about quadratic? 0 minus 1. What do I get? Quickly. 0 minus 1. What do we get? Negative 1 x squared. 0 plus 5 gives me 5x. And then negative 6 minus 8. Negative 6 minus 8 is negative 14, right? Cool? Right?
Yeah.
All right. Now, this only works if you realize that it's subtraction and you change all these signs. Everyone heard me say that. Make a big deal about it. And stress out about it. It's stressful. Teach it. Don't do it. All right. So your final answer could look like this. You know, it's up to you if you want to rewrite it like that. But when you're ready, flip it to the back. We got 2 more to do, and we'll be done with the notes. Okay. When you're on the back, example 3 is telling us to do what with f of x and g of x? Multiply. So we're about to multiply. People are still getting down example 2. Here we go. Example 3. So you see right here it says f of x dot g of x means we're multiplying. This you may have learned is called double distribution. Here's why. Every term in the first one has to multiply with everything in the second one. So we're going to do it piece by piece. Here we go. First one, first term times the first term. What's x times x? Huh? No. X times x, those are two x with one powers. What do I do with those powers? X squared. Okay.
Aha.
Write that down. Now I'm going to do x times the second term, which is 3. What's x times 3? Sorry, x times 3 is what?
Positive 3.
3x. Okay. Number, variable, stick them together. Okay. So x times 3 is 3x. Put that right next to it. Okay. You're not done multiplying because you're going to do the same thing with the second term. You're going to start with that negative 2 times x. What's negative 2 times x? Negative 2x. I'm going to put that underneath my other x term, like right there. And then, last but not least, negative 2 times positive 3. What's negative 2 times 3? No, multiply. Negative 2 times 3. Negative 6. Remember, we're multiplying here. So you get minus, oh, with a cool little, wow. Could you now add those vertically? Add zeros here. And I'm going to add them vertically. 1x squared plus 0 is what? 1x squared. 3x minus 2x is how much x? 1x. And then 0 minus 6? Negative 6. And you get your final answer. Do you see that you need to distribute everything? Everything gets multiplied, right? Last example. I wrote that. I invented that. All right, example 4. Now, this is probably the most difficult one, but it's just one little extra step. Ready? Really?
Yeah.
Real quick. Get us down. Quickly, please. No yawning. No yawning on my birthday. No yawning on my birthday. Or you have to do 20 push-ups. All right, here we go. Now, same idea. What are we doing with these? F of x and g of x? Right here, multiply. So we have a 2-termed expression times a 3-termed expression. Okay, so you can write it out like that if you want to. But we are going to do the same idea. This first term times all 3 of these, and then this second term times all 3 of these. You're going to end up with 6 different terms, and then you're going to combine the like terms. So once again, first term times the first term. What's 4x times 1x squared? So we're gonna multiply the constants. 4 times 1 is what? Whoa, 4. And then what do I do with those exponents? Add them up. So it's going to be 4 what? 4x third power. Okay, 4x cubed. Okay, do you see why that is? Because we added the 1 and the 2 to get the third power. 4 times 1 gave me the 4. Now we're going to do 4x times the second term, 1x. What's 4x times 1x? Why is it squared? Because you have a 1 and a 1. You gotta add them up to get squared. Okay? You gotta actually know how to do this. Does everyone, are y'all following me? 4 times 1 is 4. X times x is x squared. Okay? So it's 4x squared for my next term. Okay? And now we're gonna do 4x times the last term 3. What's 4x times 3? 4x times 3 is what?
12.
12x. Okay, the x is still there. And there's no constant, so you could put plus 0. Now, we just did all that work with the first term. You're going to do the same thing with the second term, that minus 2. Okay? So negative 2 times 1x squared is what? Negative 2. Negative 2 times x squared is negative 2x squared. Very good. Okay. What about, hey, listen, what about negative 2 times x? Negative 2 times x is what? Negative 2x. And then last but not least, what's negative 2 times 3? Nope. No, negative 2 times 3 is what? Negative 6. Okay.
Right.
Now, once we have all of our terms,
No, you forgot the cubic. Right? No?
this one's a 0.
Oh.
Once you have all your terms, now you can add them up vertically. So 4x cubed comes down. Okay, 4x squared minus 2x squared is what? Not negative 2. 4 minus 2 is what?
Or x squared.
Okay, 2, not negative 2.
Negative
2, what?
X squared.
2x squared.
Didn't get it right.
The sign matters, okay? What about the next one? 12 minus 2?
10x squared. 10x 1.
10x. And then the last one? Negative 6, okay? Careful with the signs, because I don't want y'all to get these wrong based on that, okay? Okay, and that would be your final answer. But you have to multiply first correctly, combine like terms correctly, okay? Now look at this. Just like last assignment, okay, we're going to trim the fat here. So the back of this has some geometric applications of multiplying polynomials. But, yes, you should have, yes. So here's the deal. Listen. Listen. Okay. If the last assignment you're supposed to do 1 through 8, turn it in. If you haven't, you can do that. I'm going to give you this. You're only going to do 1 through 6, the front side only. The back has a bunch of geometry, so if you really want to do it, have fun. But 1 through 6 is all you got to do. So I'm going to hand it to you, and you should make a note of that on your paper, right? All right, what numbers are you doing? So scratch out the back, or just go 1 through 6 in the front. Okay. 1 through 6, cool. Let's get it done.